Hello. This is a recording of the lesson that was done on the beginning of the law of sines. And law of sines just states that the sine of A, that's angle A, over side A, or divided by side A, will equal the sine of B over B will equal the sine of angle C over C. So in other words, if you have a triangle, A, B, C, so this would be side A between the B and the C. Between A and C is side B. Between A and B is side C. Well, if I take the sine of this angle A and divide it by that side, I will get the same decimal value as doing the sine of this angle B and dividing it by the opposite side. Same thing if I do the sine of C and divide it. So it ends up giving you, it's written out as three proportions. You can't solve all three at once. You always have to write it as a pair, but you can write three different pair. You could say the sine of A over A equals the sine of B over B, or the sine of A over A equals sine of C over C, or that the sine of B over B equals sine of C over C. And each one of these can be solved just depending on which information you're given. So we're not going to look so much at the A's and the B's as we are just at the triangle array that we talk about. So when we have a triangle, if this array is not given to us, you're going to want to write that. The three angles, they're three opposite sides, so you can fill this in. And then angle A would be 24. Angle B is 48. And 17 is between B and C, so that's side A. You'll always be given three pieces of information, and then you have to figure out the other three to solve the triangle. One of those pieces will always be, if not just one of the sides. Maybe two of the sides, maybe even three of the sides. But always you'll have a side. So if you have the two angles, we talked about that, using the 180-degree rule, right? They have to add up to 180. You can subtract those. And this last one has to be 108 when you subtract out the 48 and the 24 from 180. So now is when you're going to have to use law of sines. The law of sines says you have to have a pair, either both A's, both B's, or both C's to start with. Like I said, you have a pair across from each other. I don't care if it's A, B, or C. You will write that starting out. Always start with that known pair. So sine of 24 over 17. And then that's going to equal, it doesn't matter which one you solve for, you can only solve for one at a time. So if we do B, it would be the sine of 48 over B. To solve a proportion, you cross multiply. Start with the pair going across that are all numeric, right? No variables. So you want to multiply the 17 and the sine of 48, and then divide that by what's left over, which is the sine of 24. And that will equal B. Then I'm going to go over to the calculator here in a second. But the other one, and again, always start with the pair you know, which would be, I'm right up here, sine of 24 over 17 equals, and now to get C, you would do the sine of 108 over C. So that would end up being 17 sine of 108 over, so cross multiply, divide by what's left over. Make sure you include sine with that, not just 24, but the sine of 24. That will equal C. Okay, so You're going to open up your Desmos. Make sure you're just using the scientific calculator. It's in degrees, and we're working in degrees. So if you're using any other calculator, make sure you use degrees. I like just go ahead over here. A over B will set up a fraction for you. And so our fraction on top was 17 sine of 48. The bottom was sine divided by sine of 24. And that's our answer for B. And then for C, it was 17. Oh, fraction 17 sine of 108 in parentheses sine of 24 on the denominator. And for our sides, we're going to do 2 decimal places, so it'd be 31.06 and 39.75. So over here, 31.06 was the first one, 39.75. Like I said, smallest angle will always give you your smallest side, 24 and 17. Largest will give you your largest, 108, 39.75 is the biggest. That's it. Later on, we'll be doing law of cosines, which is a different law. It's a much trickier and a little bit longer to put in the calculator and do all that stuff for law of cosines. So whenever possible, you want to use law of sines. So here, L is 84. Angle N is 32. The 15 is between L and N, so it must be M, 15. And when you first look at this, it doesn't look like we have that pair that you need for law of sines. A lot of people might think this is a law of cosines problem, but it's not, because when you do the 180 rule and subtract those from 180 degrees, you get a missing 64 degrees here. And now you do have that pair that you can use for law of sines. So again, sine of 64 over 15 equals, to get L, it'd be the sine of 84 over L. Sine of 64, again, go back to the pair that you start with always. And to get N, it'd be the sine of 32 over N. Cross multiply the two you know, so 15 sine 84 divided by the leftover sine of 64. That'll give you your L. Then in the calculator, 15 sine of 32 divided by sine of 64. That'll give you N. So in the calculator, fraction, so it was 15 sine 84 divided by sine 64 and 16.60, and then 15 sine of 32 divided by sine of 64, 8.84. So there's your decimals. The bigger one was 16.60 when we rounded to 2 decimal places, and 8.84. And again, biggest goes with biggest, smallest with smallest. That checks out. That triangle is solved. All right. On this third triangle, you have one angle. E is 75. You have 28, which is between D and F, so that's E also. So we do have the pair we want. And we have another side, D, between D and E, that side F is 14. So for this one, we don't know anything about D, can't figure it out yet. So all we can do, we have the pair we want, so that would be the sine of 75 over 28 equals, and I have to use F. I can't use D because I know nothing about it. I have to know at least one of them. And what I don't know is the angle. So I'm going to say the sine of F over 14 on the bottom. This, whenever you're looking for an angle, because it gives you the sine of F, it's not going to give you the angle right away. This is called an inverse problem. You're going to have to use the inverse to figure out the angle. I'll show you what that means. So when you cross multiply this one, it turns out these two are the numerical ones, the 14 and the sine of 75. So you do 14 sine 75 divided by, what's left over is just 28, not the sine of 28, just it's a side, so just 28. What that's going to give you is the sine of angle F. It's going to give you some small decimal number, not the angle. To get the angle out of that, you have to do the inverse, which is sine to the -1 power, of that answer, of that decimal. Let me show you that on Desmos. So clear all this out. So when you end up doing 14 sine of 75 divided by, so that'll still make the fraction 28, not sine of 28. Except it's going to give you this decimal. That's the sine of angle F. So if you go to functions on your calculator, there's a -1, sine to the negative. That's the inverse button you want to use. And you want that answer. You could retype it, or right below the 3, there's a button just for that'll give you the answer back. So the inverse sine of the answer is, and for angles, we're going to do whole numbers, so 29 degrees. So angle F is 29 degrees. Well, once you know 2, use your 180 rule. You can get your third one, which would be 76. And now make sure you go back to your original pair you knew and do law of sines again. The sine of 75 over 28 will equal a sine of 76 over d. In the calculator, it would be 28 sine of 76 divided by sine 75. Again, that's the same thing in your calculator, so I'm not going to show you that, but if you put it in, you should get 28.13, which is just barely 76 is barely bigger than 75, so it's barely bigger than the side. So there's your solved triangle. So let's look at number 4. This one we see we have an angle. Angle B is 56. The 78 is between A and B, so that's side C, 78. Between B and C is side A, it's 42. Be really careful about getting your sides in the right place, your angles in the right place. So I don't have enough angles to figure out the other two. I can't figure out that third side. So this, and I don't have that pair across from each other. So this one is law of cosines. And now we're going to go over this the next few days, not today. So for right now, we just stop here. This cannot be done with law of sines. We'll move on to the next one. All right, when you have the little box, that's a 90-degree angle, so angle P is 90. And this law of sines works with any triangle. So if it's a right triangle, that's just fine. Side P is 13 between the Q and R. So we have our side across from each other, our pair, right? And between P and R is Q, so I know Q is 12. So this is another one of those where I'm going to have to do sine of 90 over 13 equals the sine of, I don't know Q, over 12. So that's an inverse problem. Because I need to know, whenever you need to know an angle, it's going to be an inverse problem. So I have to cross multiply this way. So that'd be 12 sine of 90 divided by the leftover would be the 13. That's going to equal the sine of Q. So you're going to need to do the inverse of that answer. So looking at our calculator, get all that. So that is 12 sine of 90. And when you look at 12 times sine of 90, it just equals 12. That's because the sine of 90 is 1. So whenever you're using sine of 90, don't let that confuse you because it's going to look like things should happen when they don't. Like when you multiply or divide by 1, it doesn't change the number. So sine of 90 is 1. So when you do 12 sine of 90, it just stays 12. Divided by, and that was 13. And of course, this is not the angle, that is the sine of that angle. The sine of Q. So to get the angle, you have to go over here to functions. Inverse sine of that answer means that it's 67 degrees. So come back. So I know this one's 67. Now I know 2. Use my 180-degree rule. I can find 3. So that's 23 degrees when you subtract those out. And then remember, go back to the first pair, the original pair. Or here's sine of 90 over 13 is going to equal the sine of 23 over r. So this time I'm cross multiplying the 13 sine of 23 divided by sine of 90. That will be r. That's not an inverse problem because you're looking for the side. So on the calculator with this one, now that I have 13 sine of 23, you see that answer. When I divide that by the sine of 90, I can even go back. Right, so when you multiply 13 sine of 23, you get that. When I divide that answer by the sine of 90, it's not going to change because I'm dividing by 1. So again, if you're using a calculator, don't let that confuse you. The answer is just 5.08. So it'd be 5.08. Smallest with the smallest, largest with largest. The whole thing's filled out. That's solved. All right, so on this last one, you have another triangle. This time you know 2 angles again. So y is 72. X is 54 degrees. The 26 is between y and z, so it's x. 26. And then, of course, we have our pair, so that's good. We can use law of sines. We can use the 180-degree rule to get the third one. And when you do that, this one is 54. Well, I could set up a whole sine of 54 over 26 equals, and to solve z, I would do sine of 54 over z. Well, if sine of 54 over 26 equals the sine of 54 over, well, that's got to be 26 without even doing the multiplication and divide. But we already know from talking earlier, if there are two equal angles, then I know those two sides have to be equal. I don't need to do this law of sines to figure that out. You just, that's 26, that's 26. All we need is law of sines, sine of 54 over 26 to equal the sine of 72 over y to get y. So 26 sine of 72 over sine of 54. Put that in Desmos and it ends up being 30.56. And the longest side has the largest angle, vice versa, so. And that's all. All right, so this should make it so you can do that assignment on law of sines. Good luck. Have a great day.